So in the last two mini lectures, we talked about how phenotype and mutations can affect clones or asexually propagated plants and make them look different. In this mini lecture, we'll talk about how pathogens can make them look different from each other. So there are a lot of systemic pathogens that affect the entirety of the plant that can make your plants appear different from each other even if they're genetically identical. So some examples of systemic pathogens like this would be bacteria, viruses, phytoplasmas, and phytoplasmas are just a small bacteria-like organism. They disrupt phloem transport, which means they're disrupting the transport of sugars within the plant. So all of these can cause your clones to appear dissimilar. Also nematodes, which are just a very small worm that lives in the soil that can damage your plant. They are a pest. Fungi, insects, and parasites. So to talk about the pictures here, first, the picture on the bottom left is a picture of dwarf mistletoe. Dwarf mistletoe is actually a parasite that grows on other plants, and it can really change the way that your plant looks and grows. One of the things it can do is in the top right picture there. It can cause growth that looks like this. That compact, dense growth there is not normal. That's a loblolly pine tree. You can see the branches around it look like normal loblolly pine tree branches where they're very leggy and sparsely needled. And then you have this funky looking, very dense, thickly needled area in the center there. That type of growth form is called a witch's broom, and dwarf mistletoe is something that can cause that. Phytoplasmas can cause that too. So let's talk about these a little bit. Again, a witch's broom is just a dense, very branched growth on a plant. It can be caused by dwarf mistletoe. It can be caused by phytoplasmas. It can also be caused by mutations. So sometimes it's a genetic reason, sometimes it's a pathogen reason. Now, the interesting thing about a witch's broom is if you propagate it, you can get what we call dwarf conifers. Witch's brooms most frequently occur on conifers. They do sometimes occur on some deciduous trees, but for the most part, they occur on evergreen conifers. If you propagate the witch's broom, if you use material from the witch's broom growth to propagate the plant, what you can sometimes get are dwarf conifers, which are smaller versions of the original tree. So if you look at the picture here, these are dwarf loblolly pines. If you know anything about loblolly pine, it's usually a lot taller, a lot more sparsely needled, a lot leggier in appearance than these plants. These are much shorter and denser. This is a type of dwarf loblolly pine that was bred here at NC State University. It was the result of a witch's broom that was caused by a genetic mutation rather than a pathogen. But nevertheless, that is how they made it, and so this is something where it actually can be quite desirable. Witch's brooms are not desirable if you're using those trees for lumber or something like that, but ornamentally it could be desirable because you can get this nice compact tree from what used to be a very tall, leggy tree. Which brings me to these guys. These are some of my favorite guys. I don't know them personally, but I know a lot about what they do, and it's pretty cool. These guys are in the Czech Republic. They call themselves broomers, and basically what they do is they go out in the wild searching for witch's brooms, then they propagate them and develop lots of dwarf and miniature conifers, which they then sell. You can see all kinds of pictures of this at their website, which is right there, wbgarden.com. But you see, they either climb up in the tree and cut the witch's broom down, as the guy on the left is doing. Gotta say, it's not the safest tree climbing I've ever seen before. Sometimes these witch's brooms can be really, really heavy. They could be hundreds of pounds. And in this case, a lot of times what they do is they will actually shoot it out of the tree with a gun. Which brings us to the picture on the right here. I'm from Eastern North Carolina. Sometimes in Eastern North Carolina in the newspaper, they'll have pictures just like this, but instead of holding a witch's broom with the thumbs up, it's usually somebody who got the first deer of the season or something like that. Okay, so that's what that picture reminds me of. He's very proud of his witch's broom that he has obtained. what they do once they get the witch's brooms to propagate them is they actually graft them onto a regular plant. And that's what you see in the top middle picture there. The bottom middle picture shows you examples of the dwarf and miniature conifers that they make using this whole process. So those dwarf and miniature conifers are quite valuable. They sell for pretty good prices. There's actually whole societies dedicated to miniature and dwarf conifers, so there you have it. Witch's Broom Garden. Check them out. They do cool things. Here's another example of a plant that has a pathogen that changes the appearance. Poinsettias are actually trees in the wild, and originally they were marketed as cut flowers because originally they did not grow in the shape that you see here. The one pictured here is what you probably think of when you think of a poinsettia. It's a short, dense, potted plant. Originally, the stems were much taller, much less branched, ideal for a cut flower, not really a potted plant. The potted, free branching type, which is what you see in the picture here and which is what you buy everywhere, is a result of a phytoplasma. All commercially produced poinsettias actually have a phytoplasma, and that's what gives them the growth form they have. But it doesn't have a negative effect on their health at all, so that's why they can still mass produce them even though they have this pathogen, because it changes the appearance in a favorable manner without negatively affecting the health of the plant. Now that link there, I believe I provided that link for you since you can't click on it in the presentation in the actual lecture chapter of the Moodle page, so make sure you go check that out and read it. So these aren't the best pictures, but it shows you an example of what I'm talking about. In both of these pictures, the leftmost plant is how poinsettias used to be grown. Before they got the phytoplasma, they grew a lot more upright, a lot less branching, you have a lot less flowers on one plant, and you can see how those would work quite well as a cut flower. Now if you look at the plant on the right in both of these pictures, that's the plant with the phytoplasma. It gives it a much denser, more branched growth form. That means we get more flowers in a smaller surface area, so it's very showy. Again, that's the phytoplasma. It doesn't happen a lot that a pathogen both changes the appearance in a favorable manner and doesn't negatively affect the health of the plant, but sometimes that's the case, particularly with phytoplasmas. And here's what I mean. I have a link for you, 2 links actually, about this on the course website, and do make sure that you go to both of those and read everything because that is material that you can be tested on. But tulip mania was a craze that happened in Holland back in, I think it was the 1600s. It's actually the first recorded speculative bubble economically. What happened is tulips were a fairly newly introduced flower at that time. Anyways, tulips are not native to Holland. They're native to various parts of Asia, but they were brought into Holland. And initially, there were only solid colored tulips. So solid red tulips, solid white tulips, solid pink tulips, etc. Well, after a while, they started seeing tulips that look like this. They are streaked with multiple colors, and they called these broken tulips. So it's more than one solid color, and it's very attractive and showy. People had different theories about why these tulips looked this way. They thought it was environmental causes, so they thought if you disturb the soil regularly it could cause this, or if you expose the tulip bulbs to extremely cold temperature or wind, that this would happen. However, they were wrong. The real culprit for this appearance is something called the tulip breaking virus. Now, this virus, although it does produce a favorable appearance in the plant, it does negatively affect the health of the plant. So what would happen is the tulips would get this virus, they would produce these broken tulips, and then every year, tulips die back to the ground and then they come back again in spring. Well, each year they would come back weaker and weaker until eventually they either wouldn't produce flowers anymore because they didn't have enough energy for it, or they would die. Now, the reason why this caused this big speculative bubble economically is that people were paying huge prices for these tulips. They were paying what would basically be the equivalent of 10 years worth of an average worker's pay. So, exorbitant prices for these things. And after a while, they weren't just buying actual bulbs, they were signing contracts for the promise of the bulb. So they didn't even have the bulb yet. And then what happened is the bulbs became not available because the virus caused their health to decline. They couldn't propagate them. They died. And so now you have all these people who paid these exorbitant prices for the promise of a bulb that they never got, hence the whole bubble burst. So, an interesting thing that happened there. And with that, we have finished our lecture material on Freaks and Mutants. You'll notice this is less than we typically have for recorded lectures. That's because I have the supplemental articles and videos, so make sure you watch and read those.